Okay, hello, hi guys. So today let's look at again fluid mechanics. So I have been receiving requests about this topic or chapter number two. I think we didn't do much of the examples or exercises on this question. So today we're looking at the example of question number two. So but we won't do this one. I believe that we have did this one on the previous one, so we needed to concentrate on this one now. So here we have a cylinder. I hope this one is clear. So we have a hydraulic system consists of a master cylinder with a diameter of 32 millimeter connected to a pipe to there's slave cylinder with 100 millimeter diameter, and then the force applied on the master cylinder piston is 800 newton, and the fluid has an isothermal bulk modulus of 1.8 gigapascal, and the average young modulus of the system is 50 gigapascal. And then we also have okay, before we continue, let's just write our simple hydraulic this hydraulic system. So if you can draw this hydraulic system like okay, let me draw it. Yeah, okay, let's say we have this is our master cylinder is connected with a pipe to our slave cylinder like this, but it's vice versa. The master cylinder is smaller than the slave cylinder, right? So okay, here on the master cylinder, let's have our piston here. Let's say this is our piston, and then this piston will be having the force. Let's say the force that is applied on the master cylinder is 800 newton. So we have 800 newton here, and then we have this is our slave cylinder. Let's write our slave cylinder here. Then it needs to produce this force going up now, and then we have this pipe that connects both these cylinders. So okay, let's say the master cylinder has a diameter of 35. So let's say this is our diameter of 35 millimeters, and then the side is connected to a pipe to a master. This slave cylinder has a what you call sorry, diameter of 100 millimeters, and then okay, then we have the isothermal sorry, the say here we have the fluid that has a isothermal bulk efficiency. So the isothermal bulk efficiency is our K, right? So the isothermal bulk efficiency is always it's always this K. So you have K T, which is this is the bulk efficiency, which is going to be 1.8 gigapascal. And then we also have the Young modulus. Young modulus of elastics, which is what E, it's equals to 50 gigapascal. Sorry about that. And then again, okay, let's continue. They say now the volume here, the volume of the fluid on the master cylinder and the pipe is twice the volume of the total fluid in what in the slave cylinder. So let's say here we have the slave cylinder. The slave cylinder, let's say, is VS now, and then this one, say the volume on the master cylinder, let's say, is VM for master, for S is for slave, M is for master, so that we can know. And then we also have fluid that is here, right? This is the fluid that is here on the pipe that says VP. So now they're saying the volume that is on the master cylinder and that offered of the pipe is twice offered of that one. So that means if we combine these two, is two times of this one. So that means this volume offered volume on the pipe plus the volume on the master cylinder is equals to two times what? Two times offered of our slave cylinder. And then we also have what you call total volume, right? So the total volume is actually going to be the volume on the master cylinder plus the volume on the pipe plus the volume on what? On the slave cylinder. So this makes the total volume. To say the total volume is equals to this is this two times is this 2 Vs plus Vs. So that means the total volume in the system is going to be equals to it's going to equals to three times the volume of what of the slave cylinder, right? So keep in mind on this one. So now our first question, before we move on, they said YEM, the slave cylinder, has a total stroke length of 20. Um, so the stroke length of 20 on what on our slave cylinder. So the stroke length is actually the volume that will be moved by what? By the cylinder. So let's say it's at a stroke length. Let's say it's for the length of what of the slave cylinder is equals to 20 millimeters. Okay, now we have our data ready. So the first question now, they say calculate the force exerted on the slave cylinder. So this one is simple. On this one, we know that the volume. This one we're going to use the our knowledge from N3 when when we are dealing with hydraulic press. Now, so this one said the pressure that is displayed on the master cylinder is equal to the pressure on the slave cylinder. So when you say the pressure on the master cylinder is equal to the pressure on the slave cylinder, we are saying the force, because pressure, we know that pressure is equals to force over area, and then is force on the master over the area on the master equals to the force offered of the slave over the area of the slave. So now, because these things are cylinders, to calculate the area of a cylinder, it's always a pi diameter over 4, right? Or else others, they can calculate it by pi r squared. It's the same thing, right? But most cases we're using this one, but it's the same thing, preferring what the method that you are using, right? So now to count this one, we need what? We need the force on it on the slave cylinder. That means this F is going to be equals to the area of the slave multiplied by the force on the master divided by the area on the master. And then now you get what? You get your force. So to get to this force, now we need to calculate this area M and also this area here. But to simplify things, to make it easy, because there's pressure and sorry, the area are the same, we can cancel both sides, this pi and 4, so that we can use this formula as well as the diameter on what on the slave cylinder squared multiplied by the pressure or the force over the diameter or not on our master squared. So therefore we can have what this on the slave cylinder, the diameter is what Yes, 0.1 squared multiplied by 800 over this one is going to be 0.035 squared, and then you get um your force them. So this one was quite simple. Then your force is going to be equals to 6.5 to 7 Newton. So this is the force that will be exerted on it on our slave cylinder. So now the serious questions arise on question number 2.2.2. So here now they say calculate the plane on the master cylinder piston. If the slave cylinder is applied full force at the end of it, at the end of the stroke, that means now if you're going to apply this force of if you're going to apply this force of 800 Newton fully across across this length of it, the total length of this is going to be our length or not on the master cylinder, the stroke length. So when you press this one, and then it's going to apply the full force, which the force is going to be this 6.257 Newton that we get when calculated 2.1, right? So when you apply here, there is the plane. The plane is actually talking about if you reach what your length, there will be a space that is left here, yeah, on what on the cylinder. So it's like linear expansion. Remember on linear expansion on N2 or N3, the when we heat a certain metal, yeah, when it has its own original length like this, and then when we subjected it to heat, it will change its length or it will expand like this. So when it expand now, it's going to have what, it's going to have the change in what, in length, right? It's like this now. But then now on this case it's fluid that is inside. So when you applied this force on this piston, this piston will push all this fluid to go and apply a force this side. But when it's pushing all this fluid, it will end at a certain point, so, not on the full length, right? So when it end on that point, it give us what, the change in area. This is what, from the first one is the original area here, but after applying the force, it will have what, the change in area, right? So now the free play is on this change in what, in length, or we should call it what, the change in volume, right? So this change in volume is actually what you call the compressibility of substance. Remember we talked about compressibility before. We say the compressibility, it's what you call it's K, and K is equals to 1 over beta like this. And then we say this is the coefficient of what, of compressibility. But then now this coefficient of compressibility is also okay. This is the coefficient of compressibility, right? So this is can also be calculated by what, by the change in volume over the total volume, right? So this is the total volume, and our we want what, we want this change in volume that will happen here. So the change in volume that will be here, right? And then it will give us what, this change in length. This change in length is the one that we want, which is our free play. This is the length that this foot pedal, like if it's a brake, and then when you press this one and then there is also a play on that brake, right? But if there is a play, the car won't move. If this is a brake system, right? If you press your foot pedal on your brake system, and then your brake system applied, that your car would become to stationary. And then when you are pressing it down, it will move, but then it won't release the brake system. It's the free play that we're talking about here. So this free play is we're going to get it in what, in the change in volume. So the change in volume will be equals to what? Change in volume is that will be equals to the change in length multiplied by the area of what, of the master cylinder. Because the diameter doesn't change, it's still the same as what, as the area on what, on the master cylinder. So this is what we want. Yeah. So now this one, it can be also, we can say this is actually equals to an, this is actually the volumetric, what you call, this is volumetric strain. Yes, volumetric strain. So the volumetric strain is calculated by the change in volume over the total volume, or it can also be calculated by the pressure over the pressure over the what you call the or over k, which is one, which is our bulk modulus. Now, so now we need to get what, we need to get this pressure, the total pressure, oh sorry, the total volume, and then we need to get this k. So for pressure, it's easy. Pressure is equal to force over area, as we said, and then our force is equal to what, 800 on what, on our master cylinder, over the area, which is what, which is going to be pi times the diameter, which is 0.035 squared over 4. And then we get what, let's do calculation for quick. The pressure, we're going to get 831, yeah, 831.6 kilopascal, right? So this is our pressure. For total volume, or total volume will be equals to n, will be equals to 3 times the volume of what, of our sum. So the volume of this one is going to be what, a volume, we say the volume is equals to pi d squared over 4 times length. So this is going to be the stroke length that we given, which was 20 millimeters. So it's going to be pi times 0.1 squared over 4 times our stroke length is going to be 0.02, and then we get when we get 0.000, how many, oh it's 5, it's 5 zeros, 1 2 3, oh it's 4.1 7 5, or 57, yeah, 57, like this cubic meters. So this we're going to not going to multiply it by 3, so that we get the total volume. So the total volume now will be equals to what, will be equals to our 0 point, it's going to be 0.0000471 cubic meters. So this is the total volume. So we have now the pressure, we have the volume, the total volume. Now we need to calculate what, k. So to get this k, we can also we say that this k is this one, and then we can use what, the formula of what, the effective bulk modulus, right? So remember the effective bulk modulus, or the modulus of liquid. This one is going to be equals to n, it's going to be 1 over, let's write it here, it's going to be 1 over k equals to 1 over ke plus 1 over Kc. Now, this is E, this is Kc. So here we have the Young modulus. Remember, okay, the Kc, this one is given as what? Is given as the Young's modulus over 2.5. So this Kc is this one. Yeah. Yeah, this one. That's the one that was given. Yeah. They say if the slave cylinder piston applies what a full force and or which is this K sim. No? So this KC, we explain everything on the previous video, right? When we talk about compressibilities, and then we talked also about this K C, and then KE, and also okay. So now this one is going to be 20. Is it 20? The Young's modulus, oh, it's 50, this one. So it's going to be 50 divided by 2.5, which is going to be equals to what? Should be 20. So 50 divided by 2.5, yeah, it's 20 gigapascal, right? And then the other one is going to be KE. So this KE is the one that we're given, which is this one, the isothermal back modulus, this one, right? And then the 4 is going to be 1 over K, which equals to 1 over 1.8 plus 1 over 20. So that we have what? We're going to have we're going to have K. This K will be equals to 1.65 gigapascal. Yeah. Then we are having our K like that, 1.65, right? So now we can use substitute this K here, wait, here, so that we can get this change in volume. So now the change in volume would be equals to K times pressure over total volume, right? Is it total? No, 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 no. So it's going to be total volume times pressure over K, right? Because we are making what? K subject of the formula. Oh, sorry, this one subject of the formula. This is going to be times him, and then we divide by this one. So now it's going to be 0.000471, yeah, times our pressure. Our pressure, it was 831.1. It's kilo. Let's multiply by 3. Then K is going to be 1.65 times 10 to the power 9. And then we get what? We get our change in volume. So the change in volume is going to be equals to the change in volume is going to be 0.2, yeah, 0.27, yeah, 0.237 times 10 to the power negative 6, yeah, negative 6, right? This is the change in, and this is the change in volume. So remember, say change in volume, now it's equals to the change in length multiplied by the master cylinder volume. Therefore the change in length is equals to the change in volume was 0.237 times 10 to the power negative 3 over the volume, or the area on the master cylinder, which is 0.0357 over 4. So then you get your play. This is your free play, right? This is your free play. we're going to do another question related to this one. There are quite a few number of this type of question, so we're going to do the other one on this next video. So yeah, this other one, we're going to do this one, this, yeah, going to do this question on the next video, so stay tuned. So the questions have a lot of marks, so that's why I'm trying to cover every details on them. So bear in with me, or because the time is so long, I don't know who can listen to this video for 25 minutes. Thank you. Stay tuned. Hope you're getting value from these videos. Thank you.